Hello, everybody, and welcome back to another ecology video. In this video, we're going to review what we spoke about in class about human population growth, natural resources, and take a look at a couple of graphs that you should be aware of going forward. Some of them might show up on one of our quizzes and tests down the line. So let's just dive right into it right now. Thinking about population, we have to keep in mind not only the number of people that we have, but how we are adequately utilizing different natural resources that are available to us the best way possible. If we look at this little illustration here, it's a really nice commentary at what people are doing compared to the ecosystems in which we are living in and interacting with. We're shrinking everything down. We're not leaving a lot of space or resources available for non-human organisms. I mean, look at the pictures of the little animals here. That little tiger, he looks relatively concerned that all these organisms, they're losing their habitats. They're getting kind of squished together. So by us reducing the total amount of resources in our system, it's not only plausibly going to affect us as a species, but it'll also affect each one of these other systems and each one of these other species within that system. So the big overarching concept from this group of slides were, as the human population grows, our demand for Earth's resources is also going to increase with it. How we use those resources the best possible way is kind of the idea of what we're trying to get at here. We learned in our previous video that limiting factors, they help try to maintain some specific level of birth rates and death rates in an ecosystem, trying to maintain a balance, an equilibrium of sorts. We learned that that equilibrium, or that most amount of one species that a system can hold, we refer to that as the carrying capacity. It's the greatest number of individuals that a population can sustain. On the right there is a carrying capacity chart, a very stereotypical, almost educational one that you will see for the purpose of this video. At the very bottom, you see that there is a slow growth stage that we could assume some species could be in. There's a fast growth stage in the middle. And then you have the step or the carrying capacity stage where organisms ultimately are going to end up in the system. So we have to ask ourselves, based on this graph and based on what we kind of already know about human population, where would we put humans on this graph? Would we be slow? Are we slowly developing and growing? Are we fast growing, or have we reached our carrying capacity? That's the question we want to ask. And we've reached the fast growing stage. We've been in that for a long period of time. A little more than 300 years, us as a species has been in that fast growth stage. We have just shy of 8 billion people on the planet right now. And scientists are suggesting that our carrying capacity might be somewhere around 10, 11, or 12 billion people. So we haven't quite reached our carrying capacity yet, but we are encroaching upon it. This chart shows the total population of people around the world dating back to about 1150 AD all the way up to present time, and actually shows the projected future in that orange of what a population could be. So sometime in the mid 1700s, the Industrial Revolution began that led to increases in different types of technologies that allowed our population to explode exponentially, and is seen illustrated on this chart. These include better farming equipment. We can now grow more food and farm in places we weren't able to before. Increases in medicine. If people are living longer because there's an increase in medical technologies, there's going to be more people staying around for a longer period of time. Our population numbers are going to increase. Clean water. Clean water means less chance of spreading diseases or picking up diseases in our ecosystems. And if we're in a spot in the world where their governments are able to do it, there's an increased amount of public assistance available for those countries. So yay medicine, I approve. Issue is, with the amount of people that we have on the planet, we have to be able to properly manage our resources. Our population now, compared to when this PowerPoint is made, is closer to 8 billion than the 6.5 billion that we have stated here. And there's only real two categories we have for resources. We have the non-renewable ones, our fossil fuels, and our renewable ones. The trick is, if we have more people, if we encroach upon being overly populated as a species, going beyond our carrying capacity, we're going to have to remove more forests, use more of these different resources, and ultimately we're going to end up releasing more CO2, which will cause more problems down the line. So we need to make sure that we are almost staggering the rate in which we're using our natural resources to make sure that there's an equitable distribution of them around the world. The issue is non-renewables, we use using them faster than they form. Our coals, our oils, our natural gases. Once we use them, they're gone. It takes millions of years for them to form. Renewable ones like wind, water, sunlight, geothermal, all of these are renewable ones that we can use day in and day out, and they're not going anywhere. It's never going to stop being windy on the earth. The sun's not going anywhere for at least 5 billion years. So we can use that. Water, the earth's made out of 70% water. We should utilize these other sources. Now, does it make sense to totally get rid of the other resources in favor of these? The way society is set up right now, it is very difficult to do something like that. So really the best approach is to try to integrate these renewable resources into our already existing infrastructure. That way, if something happens where our population begins growing beyond a point, some places might not have access to non-renewable resources, but maybe they can use these renewable ones. So this conversation about what is the best way to use both of these types of resources equitably around the world and advantageously around the world is definitely going to be one that's going to be discussed for years to come. If we don't do that, it's going to lead to an energy crisis that could cripple global behaviors of humans and then ultimately trickle down into other parts of our own food chains and food webs that we're part of. So we got to make sure that these resources are managed properly. Again, this is just an example. This is an example of a place around the world where the resources were not used reasonably, Easter Island. I suggest if you want to look more into this, do a Google search of Easter Island and see how they mismanaged their resources over the period of time that made it very difficult for future generations to be able to successfully live in that environment, in that situation. There are different websites that you can go to see how we as individuals are adding to this conversation. There's a thing called ecological footprint or carbon footprint that we can calculate based on our behaviors, based on what we eat, based on where we live, the type of house we live in, the car we drive, the technology we use. All of those things play into how we are kind of contributing to the global energy use. And we can begin to kind of develop some hypotheses into how we can better act as individuals in kind of that global society. Here are different factors that affect the size of our ecological footprint. How, again, I said this before, how much of a resource we use, how much waste is produced. And you can see looking at this chart, it's not an even spread around the world. If it was a perfect world, there'd be an equal amount of population with an equal amount of ecological footprint, but that's not the case. I draw your attention to North America compared to Asia Pacific. They're almost two sides of the same coin, where North America has a much larger ecological footprint compared to its population. Asia Pacific, it's flipped. The other countries, it's more leveled out. There's a better distribution of that. So in order to make sure that everybody around the world is kind of doing their fair share, you want to make sure that if you have a small population, that you're not just wasting resources. That is something we could glean from this North American chart here, that we have not as much millions of people living in North America compared to the rest of the world, but we're using the large majority of resources. That's probably not using our resources reasonably and can cause some factors down the road. This is a type of population chart that I love. It's a population pyramid. You can tell so much information from this chart. If we look at it, this one is from China from 1980. There is a website you can go to that you can find the population pyramids of every single country around the world. And if I can find that, I will link it on our Google Classroom page for us. But what this pyramid tells you is you can tell the distribution of ages of your population, the breakdown of male and female residents, the percent of population in which that percentage is, and you can glean whether or not your population is growing or declining based on the shape of the pyramid. Pyramidal shapes like the one we have here, where we have a much larger, younger generation, tells me that this population is growing. And in some cases, that can be a bad thing if we already have too many people. China needed to make sure we didn't explode and have an insane amount of people living there in the 1980s. They saw this, that in about 30 or 40 years from now, from that date, they were going to have a population problem. So what they did is they put this plan in place where they try to encourage educating people about the pros and cons of having more children and what that would do as a society in China. So they provided education to try to encourage people to have 1 or 2 children per family. They provided birth control to those who needed it. They provided financial support to those that needed it as well. And in doing so, they reduced the average number of children in their family from about 6 children in the 1970s down to about just shy of 2 children today. And it shifted their population chart to look very pyramidal to one that was more linear, like the one on the right there. That linear one is very similar to ones that you will see in more developed countries like the United States, many European countries as well. If I take the left one and I flip it upside down, so it's like an upside down pyramid, that one shows me an example of like dramatic population decline, where I have more older generations and much fewer younger generations. You see that in countries like China. Again, these are just things on here that we can do to try to help improve the rate in which natural resources are consumed and used. What can you do? Act locally within like your community. Make sure, recycle, reuse, all that fun stuff. Different environmental groups, they do things all the time that really push for us to integrate natural resources that are renewable into our system at a much better rate. This last chart is a death birth rate chart that also shows the total population based on those 2 rates. If your birth rate is high and your death rate is low, your red line, it's going to be increasing. That makes sense. If they were flip-flopped or have a higher death rate than birth rate, our total population line would be decreasing instead. So again, another population chart that you can glean a lot of information out of. On the right, and these links are on the PowerPoint that you can access on our classroom, are 3 different links. One will take you to a video on global population and give you a little more info there. The second one will take you to a page where you can find way more population charts to tell you more information. And the last one describes population pyramids in much more detail. I encourage you to check out these links to supplement this PowerPoint slide in this video if you want to find out more about those topics. So that's all I have from these slides on population growth, natural resources. If you have any questions, please reach out, let me know, and have a great rest of your day. I'll talk to you soon.